Well, hello everybody. Well, here we are again. Let me run the plans by you today. I'm going to field any questions that people would have had over section 4-3, part 1. That was over the Math Excel assignment. I'll also field any questions that people had over that skill check. And then I'll field any quick questions that people have in general. And then we will take a real quick quiz over section 4.1 and 4.2. And then as soon as everybody's done with that, I'll cover the second part of section 4.3. Section 4.3 was really divided up into 3 different parts. The chain rule was the calculus part. The composition of functions was the first part. And then the third part I left as its own day because there's so much factoring. Assignment-wise, this will be a worksheet. You'll find as you go today, the answers that we're going to get, you would not want to try to type into Math Excel. So hopefully you got your note sheet right in front of you. It's going to be a combination of some rules that we've been using already. You're going to see the product rule today. You may see the quotient rule. You're definitely going to see the chain rule. And you're going to see our chapter 0 stuff. You're going to see a bunch of factoring. Trust me, the factoring is going to be the toughest part. But look at your first one. That's the kind of problem that we did last time. That's just a regular old chain rule problem. I'm going to show you something to show that it doesn't matter. This is really 2 pieces. If I split it right there, this happens to be f of x. Don't let that confuse you with the name of the function of f of x. And then this piece is really our g of x. So we didn't do this to you last time, but this is really a product rule equation. But when the number out front is just a constant, we don't have to worry about it. And let me show you why. Let me go ahead and find the derivative of this using the product rule. I would take the derivative of the first piece, which would be 0, times the second piece. So times that x cubed plus 5x minus 9 to the 5th. We know that's going to be 0. Plus the derivative of the second, which is 5, times x cubed plus 5x minus 9 to the 4th, times the derivative of whatever's inside the parentheses, times that 5 out front. So look at what I did there. I did use a product rule on it. There's the derivative of the first times the second. Here's the derivative of the second times the first. So now if I go to simplify this, look what I wind up having. I have 5 times 5 is 25. Then I have x cubed plus 5x minus 9 to the 4th times 3x squared plus 5. Hey, the reason I showed you this one to start with is when there's a constant out front, it really doesn't matter. Because if you try to use a product rule on it, it just gives you a 0. So as long as there's just a constant out front, the derivative is this easy. Bring down the 5 and get 25. Leave the parentheses alone to the 4th times the derivative of whatever's inside the parentheses. That's how easy it is when there's just a constant out front. Of course, where am I going to take you today? Go ahead and look at your number 2 then. Notice that now the piece out front has a variable in there. Whenever there's a variable in front of there, that means we get to use the product rule. So whenever there's a variable, it becomes a product rule. So here's how this is going to look. My f prime of x is going to be, here's my first piece, there's my second piece. So I'm going to do the derivative of the first, which is going to be 6x, times the second, plus the first, 3x squared, times the derivative of the second. So using the chain rule, I've got 4, 5x squared plus 6 to the 3rd, times the derivative of whatever's inside here, 10x. What a mess. Let me simplify this a little bit then. The first piece, nothing simplifies. And when I say simplify, we're going to go try to combine any monomials that we have. So when I go to combine here, I'm going to go 3x squared times 4 times 10x. Well, 3x squared times 4 is 12x squared times 10x becomes 120x cubed times 5x squared plus 6 to the third. And trust me, we're far from done. Here comes our chapter 0 stuff now. We have to factor this. So here comes our chapter 0 stuff. And I'll kind of go slow on it. At least on the video, you can stop it, rewind it, fast forward to the next example. But look at your two monomials. Look at the 6x and the 120x cubed. We got to figure out what they have in common. Well, in common is a 6 and an x, because 6x goes to both of those terms. Now look at your quantity, the 5x squared plus 6's. I'm going to factor out a 5x squared plus 6 to some power. And that power is going to be the lowest that you see. I see a 3 here, a 4 there, so I'm going to factor out 5x squared plus 6 quantity cubed. And then I'm going to put a bracket, because I know what's coming is going to need to be simplified. Now here's what we got to do to factor. Compare this term to this first term. What would you have to multiply this term by to get this term? Well, I don't need anything to get to the 6x. But to go 5x squared plus 6 to the third to the fourth, I need a 5x squared plus 6 to the first. So that's for my first piece. Now I'm going to work on my next piece. So totally ignore this first term. Totally ignore it now. Pick on the second term now. 6 times something is 120. Well, that something is going to be a 20. X times something is x cubed. That something is going to be x squared. To go from 5x squared plus 6 to the third to 5x squared plus 6 to the third, I don't need anything. So there's where I am now. What I'm going to do now is simplify whatever's inside here. And if I do that, I'm going to have 25x squared plus 6. Final answer will be this. This derivative is going to be 6x times 5x squared plus 6 to the third power times 25x squared plus 6. And then stop. There's your derivative. Hey, so when you peek back at this, notice all this. This step was all calculus, but after that, this was algebra, this was algebra, this was algebra, and that's algebra. The reason we have to factor is soon and very soon, you'll be taking this and setting it equal to 0 to tell me what we call our critical points. So 2 down. Jump over to your number 3 real fast. So just looking at it, we have to decide if it's a product rule equation, and as soon as I see something to a power and something with a variable out front, I know I'm stuck with the product rule. I know I'm stuck with the product rule. So here comes the math part of it. Let's go f prime of x equal the derivative of the first, 15x squared, times the second, 5x squared plus 7x minus 3 to the fifth, plus the first, 5x cubed, times the derivative of the second. And the derivative of the second, the derivative of this part, using the chain rule is 5x squared plus 7x minus 3 to the fourth times 10x plus 7. Wow. There's the calculus portion of it. That's the derivative. Rest of the work is us trying to make this derivative look a lot simpler. So my first piece I'm going to leave alone. That first part doesn't simplify. So 15x squared plus, or times 5x squared plus 7x minus 3 to the 5th. Plus. And if I simplify this other part, I can simplify this monomial times this monomial. So I'm left with 25x to the 3rd times 5x squared plus 7x minus 3 to the 4th times 10x plus 7. Far from done. Now we got to factor this thing. So when I factor it, here's your first term, here's your second term. We got to decide what's in common. So if you compare the 15x squared and the 25x squared, they have a 5x squared in common. If you compare the 5x squared plus 7x minus 3 to the 5th to the 1 to the 4th, well, they have 4 of them in common. So I got 5x squared plus 7x minus 3 to the 4th. Here comes a bracket because I'm probably going to have to simplify. So at this point, ignore this second term. Ignore it. Compare this term to this term. To go from 5x squared to 15x squared, I need a 3. To go from 5x squared plus 7x minus 3 to the 4th to the 5th, I need a 5x squared plus 7x minus 3 to the 1st. 4 plus 1 is 5. I'm going to put a plus sign because that's what I see next. Now, you can look at your second term, but ignore this first term. To go from 5x squared to 25x cubed, I need a 5x. To go from 5x squared plus 7x minus 3 to the 4th to 5x squared plus 7x minus 3 to the 4th, I don't need anything, but I still need this 10x plus 7. Now my next step is, this is going to stay the same, this is going to stay the same. I need to simplify this. So I'm just going to do it right under here. If I do that, I'm going to have 15x squared plus 21x minus 9 plus 50x squared plus 35x. If I simplify this again, I can finally start combining my like terms. So I'm going to have 15x squared and 50x squared. So I'm going to have 65x squared. I'm going to have a 21x and a 35x, which looks like a 56x. And it looks like I got that negative 9. That's just that piece. I still have with that 5x squared plus 7x minus 3 to the 4th. And I still have with that 5x squared and my notation. Don't forget your notation. So here is that final answer. And remember, I said we're going to do a worksheet today. That would not be fun to type into Math Excel. One little typo and it messes everything up. That's the steps of the day. Now it's just getting you good, mainly with the factoring part. I think we're going to be good with the calculus part. So here's your next one. I got x squared times the square root of 1 minus x squared. What am I going to do first? I'm going to think of that as x squared times 1 minus x squared to the 1/2. You know where I'm going with this one. Since there's a variable out front, that makes this a product rule problem. So here goes. Derivative of x squared is 2x times the second, 1 minus x squared to the 1/2, plus the first times the derivative of the second. So I got to bring down that 1/2. 1 minus x squared to the negative 1/2 times negative 2x. The calculus part's done. Here comes some algebra for you. The first piece I'm going to leave alone. 2x times 1 minus x squared to the 1/2. When I go to simplify this next piece, I'm going to multiply x squared times 1/2 times negative 2x. If I do that, it looks like I'm going to get negative x to the 3rd, along with 1 minus x squared to the negative 1/2. So there's where I am for a second. Now it's time for the factoring piece. So I need to compare this term to this term and decide what they have in common. Well, between a 2x and a negative x cubed, I can factor out a x. I can also factor out a 1 minus x squared to the littlest power that you see. So I'm going to factor to the negative 1/2. Since that's all I can factor, let me put my bracket. Let me tell you to ignore this piece for a second and only look at your first piece. To go from x to 2x, I need a 2. To go from 1 minus x squared to the negative 1/2 to 1 minus x squared to the positive 1/2, I need a 1 minus x squared to the first, because negative 1/2 plus 1 is 1/2. And then I'm going to put a minus sign this time, because that's what I see. Now, look at your second term, but ignore your first term. To go from x to x cubed, I need an x squared. To go from 1 minus x squared to the negative 1/2 to the negative 1/2, I don't need anything. Let me simplify what's in the brackets. So I got 2 minus 2x squared minus x squared. So this piece becomes negative 3x squared plus 2. I also have in the numerator a x. This 1 minus x squared to the negative 1/2, since it's got a negative power, it goes in the denominator. So I have 1 minus x squared to the 1/2, and that is what the derivative is. Don't lose count of what that really is. What is that? It's an equation to tell you the slope of the tangent line wherever you would like to know it. Just our numbers get complicated enough, we lose track of that. I've got 2 more to do with you. I'm going to do number 5 and number 6. I'm not going to do number 7. So on number 7, or number 5, I guess, there's 2 ways to do this one. We can do this problem by the product rule, and I'll show you why, or we can do it by the quotient rule. I'm going to let the class pick. That's why that YP there. You pick. Since this is a video, I'm going to pick. I'm going to show you how to do this one by the product rule. Is it easier? I don't know. It's 6 of one, half dozen of the other. So here's what I'm going to do. So that I can use the product rule on this, I'm going to think of this as 3x squared plus 6 to the first times the quantity 5x minus 12 to the negative 4th. I just brought that quantity up. We did that sum last time. Since I know this is a long problem, I'm going to start way over here. So here goes the derivative part of it. I need to go the derivative of the first piece, 6x, times the second, 5x minus 12 to the negative 4th, plus the first, 3x squared plus 6, times, don't forget this is times, the derivative of the second, which will be negative 4, 5x minus 12 to the negative 5th, times 5. Doing the chain part of it. take your time and simplify this. So I got 6x, 5x minus 12 to the negative fourth. And then let me try to simplify out here. Just go grab your monomials that you can simplify. And in this case, that's just negative 4 times 5. So I've got negative 20 times 3x squared plus 6 times 5x minus 12 to the negative fifth. Woo! Now we're finally ready to factor. So compare this term with this term. If I look at the 6x and the 20, all that they have in common is a 2. If I look at the 5x minus 12 to the negative 4 and also to the negative 5, we're going to factor out the one that's smallest. So there's what I'm factoring out. 2 times the quantity, 5x minus 12 to the negative fifth. And then put a bracket, ignore this second term, and only look at your first term for a second. To go from 2 to 6x, I need a 3x. To go from 5x minus 12 to the negative fifth to 5x minus 12 to the negative 4, I need to add 1, so I need a 5x minus 12 to the first. So that takes care of the first term. Now pick on the second term, so don't look at the first term. 2 times something is negative 20. That something is negative 10. To go from 5x minus 12 to the negative 5 to the negative 5, don't need anything. But I still have this 3x squared plus 6. So there's that piece of it. Now we just got to simplify. So I'm going to have, I'll go ahead and just bring this down this time. 2 times 5x minus 12 to the negative fifth. And let me simplify inside here. I'm going to have a 15x squared minus 36x minus 30x squared minus 60. So if I simplify this, I spy a negative 15x squared minus 36x minus 60. That's that piece. Also in the numerator is this 2. And in the denominator is this 5x minus 12 to the fifth. And that is what that derivative winds up being. You could also, if you see it, there's a 3 or negative 3 that goes into all of these. You could take out a negative 3 if you wanted and have a negative 6 out front. And then if I take out a negative 3 out of those, I'd have a 5x squared plus 12x plus 20 over that denominator. If you didn't see that, no big deal. That's a beautiful answer. So it looks like I got one more to go with you. Hey, the frustrating thing today, calculus, and then algebra, 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 algebra. A ton of algebra today. Here's my last one. You're number 6. I've got 10x squared over 3x plus 1 to the 6th. I'm going to show you what this would look like via the quotient rule. Like I said, to be truthful, in this case, 6 of one, half dozen of the other. Both of them's got a ton of algebra in there. This one's a little bit easier problem than the other one, though. So here goes this derivative. Last one. The derivative of the top, which is going to be 20x, times the bottom, which is going to be 3x plus 1 to the 6th. Not negative 6, because I'm using the quotient rule. So it's just the derivative of the top times the bottom, minus the top times the derivative of the bottom, which would be a 6, a 3x plus 1 to the 5th, times 3, the derivative of whatever's inside the parentheses, all over 3x plus 1 to the 6th squared. And we won't leave it that way, because a power to the power, you multiply your powers. So this really becomes 3x plus 1 to the 12th. And then, of course, we're far from done. Now I got to simplify this thing. So the first piece I'm leaving alone. 20x times 3x plus 1 to the 6th. This other part, though, becomes negative 10x squared times 6 times 3. So it becomes negative 180x squared times 3x plus 1 to the 5th all over 3x plus 1 to the 12th. And we're not done yet. I still got to simplify this. So here's what I need you to look at next. This piece right here has 3x plus 1 in it 6 times. This piece right here has 3x plus 1 in it 5 times. And the bottom has 3x plus 1 in it 12 times. Hey, so if you look at the 6 and the 5 and the 12, the 5 is the smallest amount. I'm going to take away 5 3x plus 1s to the 5th. I'm going to take away 5 of those. So here's what I would have. Out of that first piece, I'd have a 20x, and I'm taking away 5 of these. So I'd have 1 left, 3x plus 1. Out of the second term, I'm taking away all 5 of these. So I got 180x squared. Over, and remember we're taking away 5, so it has 12 of them. I'm taking away 5 of them, which leaves me 7. It's the same thing, guys, as factoring out 5 3x plus 1s and then canceling 5 of them out with the bottom. And then we're almost done. Let me distribute this top. So I've got 60x squared plus 20x minus 180x squared. I think I'm off somewhere. I should have a 60x. Oh, just plus. So I got 60x squared plus 20x minus 180x squared over that. And then I'm just going to combine my like terms. So it looks like ending answer, f prime of x is going to be negative 120x squared. That's what I got when I combine that and that, plus 20x all over 3x plus 1 to the 7th. So that's part 2 of section 4-3. Pretty tough. Not really hard, but a lot of algebra in there. The assignment is a worksheet. Like I said, I was going to have another one, but I decided not to do that. So we have a worksheet on that one. You'll probably need to do that on a different sheet of paper, because I definitely didn't leave you enough room. The problems are kind of close, so in a different sheet of paper, do those, space them out, write as big as you need, and good luck. If you didn't get that quiz taken prior to today's lesson, remember we need to get you in and get that quiz taken also. Good luck.